Boom. Okay. So each of the lectures that I give you, we gave you a schedule which anticipated a set of lectures. And each of them is associated with an articulated set of lessons that you may wish to reflect on following each of these models that we build up. They're designed to teach skills, yes, with the platform, but also principles. Principles in terms of their sort of about agent-based modeling more generally, etc. Okay. So what I'd like you to do is to come here, and we are going to go and create. We've created this model. You'll notice that by virtue of creating it, we have a main class, and we have a experiment. Too loud? Okay. That's nice. My throat could use a break. So I suspect I may be educating the broader building here in the fine art of building a model. Okay. So ladies and gentlemen, we have within this model a main class, an experiment, a database, and some aspects of sort of run configuration. I'd like you to go now. We're going to add in a theory of personhood. Remember, these models help us capture and operationalize theory to ask about its logical implications. We're going to do new. We're going to ask here for an agent type. So to do this, we right-click on the model. We say new agent type. And I'd like to call our agent person. Okay? Person. We're going to articulate a theory of personhood, what it means to be a person with respect to this model, a theory of personness. And we're going to have many particular people who are particular manifestations of personhood that vary in their particulars, but we're going to have a single theory that unites them. So we're going to say finish here, and you'll notice that it's created this little person. And that person is lent, then a Da Vincian icon, shown in red, which is illustrating the fact that they're an agent. Notice that somewhat confusingly, main is also an agent here, but that's a technical detail we won't dwell on. So we have a theory of personhood, and we're going to lend this person an appearance, lend them a face upon the world. So to do this, we're going to go to the palette, and we are going to drag in to the palette a very simple representation for them visually. So we're going to go to palette, we're going to go down to presentation, and we're going to drag in an oval to them. How do we do that? We go to the palette down to the down to this visual representation, and we drag in an oval. And this thing is being truculent, but we drag in there like that. And I'm going to try to center it on these crosshairs, which will mean it'll be centered where their logical location is. When we have an oval like that selected, you'll notice its characteristics are shown over here on right. We can engage in frobbing behavior with it visually, but it's often easier to just adjust things over in position and size. So I'm going to lend it a radius of 10, and that will make it smaller while centered at the same point. Okay? Are people following along? Aiden, do you think we could get backup TA help? Because the plot will be thickening. Alex, Alan, Rifat, okay. We've got some, but I think we need more. Okay. Tina. Okay. Now we're cooking too. Okay. So we just added an appearance for the person. Do you see that? Okay. I'd like you to go now, and I'd like you to go back to main. We've lent a person at least some attribute. We've lent him a face upon the world. I'd like you to go to main. Now, main is Ladies and gentlemen, person describes the theory of personhood. Main describes the global system depicted here, the world as it were, according to this model. It's the stage on which the agent struck, okay? We're going to have remember, agent-based models are defined by one or more populations of agents. So we need to have, in addition to every theory of personhood, we want to add a specific population. There can be more than one population in a model. There could be one for Vancouver, another for Toronto, and another, ladies and gentlemen, for no less than the fair city of Saskatoon. So we're going to drag in, we're going to go to main, and one of the most important things you want to do when you're working with a model, particularly early on, but even for the most experienced amongst us, is you want to make sure when you're going to add something, you're adding it to the right thing. We're going to add this into main, okay? We're going to go and we're going to drag, click and drag on person and drag into main, just like that. Okay? And I'd like you to go change it so that the name for this is not person, but population. Okay? Okay. Population. How did I do that? Ladies and gentlemen, I went to main, I clicked on person, and I dragged over and let go of the click. I clicked and dragged and let go when it was over this canvas. Who needs TA help? We are now well stocked with TAs of formidable collective power. Who would like to secure their help? Okay? Okay, ladies and gentlemen, we have, however, as yet a misnomer here. Population here is labeled as population, but as of yet, it's not truly a population. If we go over here and we look at the properties when we select it, you'll notice it says it's still a single agent. We need to turn it into no less than a population of agents. We do that with this button here. And by so doing, it changes the appearance to something that's followed by square brackets. The semiotics of this may not be clear to most in the room, but when we have square brackets like that, to those from computational background, that denotes a collection of these things. In fact, what's called an array, sort of a linearized collection. And you'll notice the dot dot, meaning there could be any number of different individuals there. Okay? So we want to go to population of agents. We'll leave it at 100 at the moment. Before this session is out, you will bend that to your will and be able to change it as you see fit at a time of your choosing. Okay? Okay, so we have this population now. And ladies and gentlemen, I'd like here to go and I'd like you to, for the initial location here, specify that we're going to place them in a specific point. Okay? Visually. And in fact, logically, we're going to locate them. The x-coordinate will be drawn from a uniform distribution between 0 and 500. And you'll notice that I'm writing with malice of forethought, 0.0 and 500.0. It bears being careful about how you phrase numbers within any logic by extension, the platform on which it's created, Java. And you want to often emphasize this is a number, a so-called floating point number, not merely an integer. So between 0 and 500 there, okay? And I'll say that for both x and y, okay? What this is saying is, for each person in this population, I'm going to lend them an x position as drawn from this distribution. It's going to draw from that distribution, and it will draw their y location from this distribution. Do you see that? Who needs a bit more time? Okay. I believe I should lower my voice yet further. Okay. Ladies and gentlemen, I'd like you now to right-click on simulation and run. And what you will see is a logical consequence of what we put in there. What are we seeing? 100 people, and where are they located? At random positions between 0 and 500, 0 and 500. Good, good. We have a population. In fact, if you go up to this root, we computer scientists are perhaps we stand out in the distribution of choosing adverse names for things, names that people find odd. Computer scientists will talk about root, meaning that the top of a hierarchy. It's perverse because you think of the tree as the root of a tree, the lowest thing, but it's actually the highest level category. Everything else branches from it. So we're going to pick root there and go down to population, and we'll see that actually there's 100 people in this population. We can go between them, but their appearances are singularly the same. And so they don't look all that different. Soon enough, that will be different. They'll be different, and we'll see those differences. Okay, so we just ran that model. I just closed its depiction. Okay, we have some heterogeneity. It's baby steps, but steps nonetheless, ladies and gentlemen. Next, I'd like to introduce into this model a characteristic associated with each of those persons beyond their appearance. Right now, they have only one attribute, which is some appearance. We want to lend them something with more significance than that. So let's go back to person. We're going to add to person a characteristic. Let's go up to agent. So we click on person here to indicate we want to add this to person. We go to the palette. We'll go to the agent palette, and here from the agent palette, we will drag over a parameter, and this will be called age. For some models, ladies and gentlemen, we represent age as an aspect of state, something that's changing over time. For this model, given the scope to which we aspire, we'll treat age as a constant. Maybe we're simulating a fast-moving phenomenon like a seasonal flu epidemic, and we're really not. It's not material to our goals that we capture changes in age over that time. In that case, we might represent age in a static way. In other cases, if we're simulating a long-standing disease like diabetes, we're simulating the impact of early adverse childhood experiences on later life outcomes. Changing of age and captured developmental periods may be critical for the goals of our model, and we never think about representing age in a constant way. Remember, models are simplifications of the world, and what they simplify out, what they hide, what they use, they cut out using the logical knife of model purpose will differ based on that model purpose. So we're going to add in age as a characteristic of each person. So with our theory of personhood has been broadened, ladies and gentlemen, to include age. Okay. Let us now go and repair ourselves to the model project here. Okay. We've just gone back to the model project, and I'd like to go back to main. I'm going to click on main here, and we're going to go, ladies and gentlemen, down main. Okay. And we're going to click on population here. Okay. We're clicking on population. I'm pleased to see a formidable phalanx formed in the back of TAs. Okay, so we're going to click on population. You'll notice now population has something different about it. What's different now that wasn't there before? Age is present. We need to specify for this population some assumptions about the age of the individuals within the population. If we had one population for Edmonton, another for Saskatoon, we'd have perhaps different age distributions associated with each. Now, if the hour were early, I would suggest that we add a custom distribution for age. where we draw people from a custom distribution, their age. And if there's demand for it, I'd be glad to do that now. My thought is to draw it from a simple distribution. Does anyone really want to see a custom distribution? It will add about 5 minutes to our little model building here. Custom distribution? The ayes have it. We will add it now. Okay, so we're going to draw age from. We have a theory of personhood that includes age. For this particular population, we're going to have an age distribution that we want to associate with people in that population. Age, as a general characteristic, is described by personhood, but the particular distribution to use for this population or that one is not an aspect that we specify in person directly. That distribution is an aspect of the population. So we're going to add into main, reflective of that, from the palette, something called a custom distribution. Okay, do you see that? It lies in the agent palette that sits before us. Yeah? So we drag in a custom distribution from the palette there. Click, drag, and it lands like that. Okay? We're going to change its name to age distribution. Again, if there were two populations, we might have two age distributions. Ladies and gentlemen, we're going to add in here, we can specify an age distribution for different types of things, for a continuous variable, discrete variable, or for particular categorical items, such as what fraction are male, or the number that are male versus female, for example, or the number that are in a non-smoking state, a current smoking state, or never smoking state, current or former, for options. Here we're going to do continuous, and here we have as yet a set of options. We can do it in ranges. We can say how many are in a certain age range for different age ranges. We can do so with a frequency table, saying how many times do we get a certain values, proportionally speaking, or we can specify it with samples from which we wish to draw. Here, we will make use of a range specification. And you'll notice we could say, okay, do we want to load this range from a database? There are ways we could even load it from a file separately, but I'm going to simply specify it inline. So I'll say from 0 to 10, we're going to have, maybe I'll say from 0 to 5, we'll have 100 individuals. These are sort of relative numbers. From 5 to 10, we'll have 98. These are densities, ladies and gentlemen. These are sort of, you can think of them as people per age per year of age. They're not the total number that lie in that so much as within that band, what's the density of people per age. So I can say, for example, from between 10 and 20, maybe we have 97. In the impetuous years of youth, there's some risks. And from 20 to 50, we're going to associate it with 95. From 50 to 60, we'll have some of the deprivations of early chronic disease losses. From 60 to 70, the numbers decline yet further. And from 70 to 80, the losses are magnified. At 85, that's probably a high overestimate. We have a remarkably healthy population. From 80 to 90, we're down to perhaps 50, and between 90 and 120, we'll have very few. 90 to 120, we'll have profoundly few individuals in that most aged of categories. Okay, so this gives us a sense of kind of how many people are there per year of age in each of these areas. You'll notice below there's a preview, and I don't actually find this super helpful, but it will give you kind of a graph of what that distribution looks like visually, which shows sort of the changes at different levels of it. It will draw from that distribution a certain number of samples. Okay? So this is our custom distribution. The people demanded it, and I delivered. So having done that, we have to make use of that distribution. We've just defined it, but just as a theory of personhood lets us create many particular people, that distribution, defining that distribution lets us draw from that distribution. And where would I specify that I want to draw from that distribution? Where within this interface that lies before us? Under age. So just as we drew their X and Y locations from this, we're going to specify there that we need to draw from the distribution. And ladies and gentlemen, I will be remiss if I don't emphasize a point of learning early, a point of learning often in this boot camp. We want to use autocomplete. Start typing age, press on PCs, control space. On Macs, the requisite key is control space. And you'll notice the choices that are provided. All of them begin with age. The more we specify, if we say age, it gives us two choices. Now, I have to trouble you with an ugly fact. We want to draw from this distribution. We want a particular number from this distribution. This first one may look alluring. It may be seemingly recommended by its simplicity, but you actually need the second. The second gives us a double precision value back. The first is actually specifying a whole distribution. We're saying this person's age is this distribution, which doesn't make a lot of sense semantically. So we want age distribution, and we need to call it. When we were yet in high school, or perhaps amongst the precocious in early years of junior high or middle school, we learned to write, for example, sine of 90 degrees or 2 pi radians or what have you. And we write it with parentheses around it to say that, that the things in parentheses are what sine needs to do its job. In order to do its job, it needs to be specified an angle of which it should take the sine, right? There are some we took, for example, a tangent, and it might have 2 numbers in it, for example. So in general, when we write mathematical notation, we put parentheses around the things that, if we're applying something, what's inside the parentheses are the things it needs to do its job. Age distribution doesn't need anything to do its job. We just call it, it gives us back a number. And so we have to put this open parentheses, close parentheses. But it is something that we need to accommodate. Just like uniform needed these 2 numbers to do its job, and it gave us back a single number, a double precision number, age distribution needs to be called with nothing, okay? But this is calling it. It's saying it's requesting a number from age distribution. Are we okay with that? Ladies and gentlemen, let us see what our efforts hath wrought, okay? So let's run this model. We can do so with alacrity. I would recommend that you think about building the model, however. There's a thing up here which is labeled with 1s and 0s, okay? And if you build it, it will tell you if there's a problem. You'll notice mine said build completed successfully, and it gave a bit of information. But that's an indication that it understands what we mean by the model. What we've told it to do by the model, it understands. And pressing this button is often good because you want to see, does it understand what you're telling it, okay? So you can press that button, but in this case, we will go run this model. How do we do so? Where do we go to run this model? If I wanted to navigate this interface to go run it, what would I do? Where do I go from now? This palette stands in front of me. What do I do? Project. And it turns out there's several ways to run a model. That is the one I most recommend because it's the most specific. It eliminates a lot of uncertainty about what you're running. You can go here, having been there, we can right-click on this and do run. I would note, however, that my model has a star next to it. That star denotes that it's not yet saved. Okay? It's actually not a problem for running it, but it indicates to me that it's at risk. If my computer were to suddenly shut down, if any logic were to suddenly cop out, which occasionally happens, I might lose that. So I'm going to press save. I tell my students, save early, save often. There's only been 1 or 2 times in my entire life where I've ever regretted the fact that I saved too early. I remember one of those times rather vividly. So I'm going to right-click on it and say run, okay? Alternatively, you could go to model and say run and choose what you want to run. Alternatively, you could do so through this button up here. You can pick your mechanism, but I like right-clicking on the particular experiment because it makes clear in my head which particular experiment I'm running. I'm going to do run, and at first blush, we don't see anything different. If we wanted to see, however, the different ages associated with those agents, where would I go? Yeah, I'd go to the population, I'd drill down to population, and here's someone nearing retirement. Here's a young whippersnapper. Here's an individual in the fullness of middle age. Well, okay, they're still young. Here's someone, again, in older age. Here's a rambunctious teenager. So we do have a population that's of different ages here. It would be nice if we had some illustration of that. If we had some way of visually seeing that. So let's go back to person. And let's go click on the oval. Ladies and gentlemen, we're going to make this oval have a radius that's given by their age. So the older they are, the bigger that oval will be. Okay? And we're going to put in a particularly naive rendition of this. You'll notice I'm going to the oval because it's about the oval that I'm setting this characteristic. It's the oval size I want to determine, therefore I go to the oval. It's within person, so I have to go to person first and find the oval within them. Having selected the oval, in the interface I can see its properties. Alternatively, over here, and this is an important point, I find my students often floundering over here in the interface. Alternatively, I can go to person, I can go to presentation and select the oval from here. That's another way to do it that often prevents us having to search around on the palette. We can ferret it out through this area of the interface, through the projects, the hierarchical depiction. But what I want to change with the model is what? What do I want to set? If I want its width of that oval to be determined by age, what do I want to do? Yeah, I want to set the radius. Now, this brings us to an aspect of the AnyLogic interface of note. You notice that this is set right here, just saying equal. And if we attempt to say, well, I want to make the radius equal to age, it will exhibit displeasure. Okay? I want you to do this, but I'd like you to watch as I elicit displeasure from AnyLogic, because I have a certain familiarity of taming its displeasure. Okay? So I'm going to start to type, and it will say invalid number. It's not happy with that. I'd like to say age, but it doesn't know what I mean by that. So I'm going to change it back to a number, and I'm going to change that little equal sign to this thing that indicates, actually it's a quantity that may be recalculated over time even. And I'm going to say age. Okay? What do you think we'll see if we run this model now? what apparition will lie before us? How will our view be different? Yeah, we'll have different by age. So each individual will be associated with a depiction that associates them with a certain age. So these individuals who are older, like this 164, they'll have a larger age. This other one will be 4.8. They're a young sapling. This individual in their 30s, they're middle size. Okay. In the fullness of time, we'll see how their appearance can even change over time. That will be tomorrow. But we'll see they could just grow them automatically. We'll say we want their current age, and as that changes, they will grow. But we see that we could reflect in their characteristic aspects of their in their visual characteristic aspects of their particulars. Okay, so that much is good. But I'd like to add some further richness to this model, ladies and gentlemen. After all, one of the things at which agent-based models excels is capturing heterogeneity. If we have a population that's heterogeneous, and that heterogeneity matters. It's not merely incidental, hair color and the vagaries of their exact height, but things that matter to our research question, to our key things we're trying to solve with the model, things that we posit are important, or things that have a disproportionate impact. We often want to represent it. So the next of them that I want to represent is a person's sex. Okay? So we're going to add in here a depiction of the sex of a person. Here we go. We're going to add in, we drag it from palette to person, from parameter here in agent. Next time you're going to tell me. We're going to add in their sex. Now, you notice I put this in lowercase. Would you mind varying me some tea? Thanks so much. It doesn't matter to me. It's heat, as long as it's not freezing. You notice I indicate this in lowercase. They're going to have, each person in the population had a particular age, and each person will have a very specific sex. But the quandary faces us. How do we encode their sex? Is it a double precision value? We can go pick here. Thank you. Is it a Boolean? With women being the truer sex. So we have true for women and false for men. Or do we wish it to be an integer, 1 and 0? I don't recommend any of these because a 1 and 0 for sex might be confused with a 1 or 0 for urban versus rural, or with the numbers associated with each of the provinces in Canada. 0 might represent Newfoundland, Labrador, and we might confuse it with a female sex. We don't want to make use of that. We have more robust mechanisms that are afforded us here. So in order to do that, I'd like to show you a new feature. Within projects, we're going to go add in something that's going to encode the set of possible sexes. Person with a capital P denoted the sort of theory of personhood, all possible people. And I'm going to add into our model, I right click on it, say new, and I'm going to add in an option list. I like to think that this option was added to AnyLogic after the CEO of AnyLogic came to one of my boot camps. And he was seemingly very happy about the boot camp, but horrified that I introduced a way of doing this. Because AnyLogic didn't have direct support, I introduced it by introducing a tiny bit of code for what are called enums, and I think it distressed him that people had to do that. So they added this option list. And it's going to be called capital SEX, just as we denoted personhood, set of all possible people, as it were, with capital P person. we're going to note set of all possible sexes with capital SEX. A particular person, we indicated lowercase sex, indicate that a particular sex. This indicates set of all possible sexes. So I'm going to have male and female as the two sexes. Yeah. Okay? As two sexes. For certain purposes, if we're representing encodings in a database, we may want to represent people who are not comfortable with designation with one of these. But for now, I'm going to leave it like that, and I'm going to say finish. So I put a name here, and I clicked here, and I specified male, and I specified female. Who needs TA help? The TA stand ready. TA needed in sector 3. Sector 3. Okay. The phalanx, thank goodness Alexander's phalanxes wouldn't have gone as far if they had been encumbered by checking cell phones. Ladies and gentlemen, I'd like you to press finish, and you'll notice now we have added to the model sex as a characteristic. Okay? Now, having done that, having described the fact there are sexes, we can go back to person and select the sex characteristic of a person. And now, what will its type be? Will it be a number? A string, perhaps? What will its type be?
Sex.
It'll be sex. In fact, it's in part of our list now. We could select its type to be the sex. Okay? So now we'll associate them with a particular sex, male or female. Okay? This characteristic of a person, age will be specified by a double precision floating point number. Sex will be specified by an element of the option list, either male or female. Are we okay with that? Okay, now we could run this model, but before we do that, what do we still have to specify? We indicated that our theory of personhood includes that each person has a sex. But what do we still have to specify? Sorry?
How to pick.
Yes, precisely, Gabrielle. That's exactly right. Was it Gabrielle? Yes, okay. Very good. So from population here, we need to specify something about their sex. Now, I could go and I specify a sex distribution. That would add about 2 minutes. Do people want to see how to do that? Okay. The ayes have it yet again. Okay, 2 minutes I can spare. From the palette, I'd like you to repair to the agent palette. Here. In the agent palette, there's a custom distribution. We dragged it in before. This is going to be called, not age distribution, but anyone want to hazard a guess? Sex distribution. What sort of distribution will it be? It'll be an option distribution, because we added, remember what was called an option list, associated with sex. So it's a draw from an option, okay? And here we're going to pick the option list, and we'll pick sex, which is the only one. And here we'll indicate the relative number of individuals. Let's suppose we're dealing with a situation where we have somewhat more females than males, so we'll have 53% and 47% of the population. Okay? So how did I do that? I chose from the sex distribution, I named it, chose option list. I picked the particular option list, and it populated this, and I clicked there, filled in 53, picked here 47. Do you see that? Okay. So this is just specified a custom distribution. We could have loaded that as well from a database. My TAs could show you how to load it from a spreadsheet. But in this case, we simply typed it in, as with the age distribution. Ladies and gentlemen, how do we draw? Where do we need to draw from that sex distribution? In the Remember, theory of personhood specifies personhood as a general phenomenon. If we want to specify the particular sex sort of associated with people, where do we go and do it? In the population. So we go to the population, and for the sex, we'll say sex distribution. We'll draw from the sex, but don't type it out, ladies and gentlemen. To do so risks errors, and it encumbers yourself. Say sex, space, control space, and pick this one that involves these begin parens, end parens. Why begin paren, end paren? Because we don't need to provide it any information, so it just, you say, draw from the sex distribution. Here. Are we okay with that? Yeah. Okay. What would happen if we run the model now? Would we see anything different? Shall we run it? Okay. We might again want to build, just make sure things are hunky-dory. I'd run the model here. Okay. Here we go. And we will see here in the model, if we go down to population, here we have a male, here we have a female, here we have a male, here we have a female. Now you may notice something. Perhaps a creeping horror is set over you. Perhaps it did in the first moments of the boot camp. But you may have noticed that every time we run this, we are associated with the same basic characteristics. Every time we run it, the very first person in the population is a 64.1-year-old male. We could run it again and again, and even, ladies and gentlemen, until the cows come home, and we will see exactly the same characteristics. To some, that may be reassuring. We have predictable results. To others, it may be disconcerting. After all, is it one of the strengths of agent-based modeling? We can explore the impacts of uncertainty on model outcomes. Rest assured that both needs are met. Ladies and gentlemen, if you click on a given simulation, repair to the properties window. If the properties window for some reason is not visible, you can make it visible through the view menu. I've just disabled it. I've just now enabled it through view and clicking on properties. If you go slightly down it, you'll find that there's a section called randomness. You may need to expand it. This is an expander area. You may need to expand it, and you'll notice it gives us several choices. It says, do we want each run to be different, or each run to basically be run with the same so-called fixed seed? It's the same basic assumptions, the same basic sequence of random numbers generated. Or do we want a custom generator? We'll do random seed instead, and now we will benefit from a diversity of outcomes. One run through the model, the very first person in the population will be a 44-year-old female. Another run in the model, the first person in the population will be instead a 48-year-old male. In short, for a given experiment, we have the option of to what degree we want things to vary. In certain cases, paying attention to this option, such as parameter variations or stochastics, paying attention to this assumption is mission critical for getting what you want to see. Here I've changed it to random seed. But in other cases, like where we're preparing a manuscript for publication and we want a reproducible result, maybe we want to use the fixed seed. And we specify a seed. And from then on, we want to have exactly that seed. Yes? Yes?
Just a question on the seeds. So are all the seeds, they all work? Or there's been other simulations that I've done where we have to pick seed numbers that were the right ones. Otherwise, they were correlated or the rich to that.
Good question. So all these seeds will work. There are rare instances, and Winchell could speak about this with particular fulsomeness, where you may want to be extra careful about the how you generate the random numbers in your model. There are cases. Suffice it to say that AnyLogic makes use of standard, what is called Java, the programming language Java, tools for generating random numbers. And it uses a very modern algorithm to generate them. But there are cases where, because of very particular needs or great sensitivity, we want to be quite careful about what we want to generate. And you can actually make use of a custom generator that will draw things using a more sophisticated mechanism. And you can do so with this thing called custom generator. Winchell has some experience with that, and he has argued, lending me some degree of confidence that he may be right, that there's cases where you want to pay attention to this. And if you were interested, you could speak with him about his conviction that in certain cases it's important. I have not personally come across enough evidence to find it convincing because of the sophistication of the built-in one. But I'm open to the idea that at certain times it may be particularly important. And if Winchell believes it, I'm inclined to believe it, because he is at that level of sophistication where I trust his judgment as much as my own. Okay? Yeah. Okay, so ladies and gentlemen, we have different sexes, and I'd like to suggest that we color these indicators, these ovals, color these characteristics of a person according to the person's sex. Okay, how would I do that? Where would I go if I want their appearance to have a color based on their sex? Where would I go?
Person?
Yeah, so I need to go to person because after all, I'm shaping a characteristic of a person. And where within person would I go? Yeah, I click the oval. Even though this is about sex, it's really more fundamentally, I want to change the characteristics of the oval, not the characteristics of the sex assumptions. I want to change the characteristics of the oval. So I have to go to oval here. And you'll notice under oval, there's a little area that's called appearance. I'd like to change the so-called fill color of that agent. Have their color be dictated by their sex. But I'm left in a quandary. How do I do this? After all, I see, okay, I can try to pick a color. I could try to pick one of these colors, but after all, that's just going to give a color for everyone. How would I make it specific to their sex? What do I do here?
Dynamic.
Yeah, I need to make it dynamic. I need to click on this, okay? And give a little formula for this. Give a bit of logic associated with it. Okay. Now, I have a secret that I'd like to share with you. For some, it may be empowering. For others, you may fear it. Ladies and gentlemen, all of you will leave this room this evening confident in the understanding that you are now, whether intentionally or not, a Java programmer. What you have been entering thus far, these little snippets to call the age distribution, to draw a number from a uniform distribution, those are nothing less than bits and pieces of code written in the Java programming language, which is one of the most popular extant programming languages out there. And any logic models are built atop with all the strengths and encumbrances attendant upon it, this platform of Java-based programming. What that does mean is we can afford ourselves access to a wide variety of tools for building models and understanding them and debugging them and understanding where the performance bottlenecks are. But it does sometimes mean that we must accommodate ourselves to the dictates of that language, to the strictures which it imposes on us, and yea, even to the dictates, I fear to say, of the American Imperium, to the level of specifying what spelling we use for words of cherished alternative spelling within Queen's English. as we will see, color is spelled without a U, if you can imagine it. And neighborhoods also lack that defining U. So here, for fill color, we're going to specify a little bit of logic. And that logic will be subject to the dictates of this language. So what I'd like to do here for fill color, I need to introduce you to a little bit of syntax. And I ask your pardon for it, particularly so late in the day. And particularly with an instructor who has so taxed your patience. So within the fill color, I'd like you to say random true and use autocomplete. That will befriend the TAs because they'll have less to correct, risk of misspellings. I'd like to say, this is not random true. I stand corrected. We want their fill color to be dictated not by uncertainty, but by their sex. So this is what I'd like to say. If their sex, now I could say if their sex equals female, we will make them their color yellow. And we can specify either in all lowercase or all uppercase. I'll say all lowercase. Or if it's otherwise, we'll make it gray. And I must confess, I always confuse how to specify a color or how to specify the last name, but I believe it's with an A. Okay, now this is technically correct, but I want to be a bit more specific about it because there are some contexts where it will bite you. So I'm going to say this dot sex, meaning my sex, my specific sex. It's the sex associated with me, not associated with some other person. We don't need to do that. It'll work like this, but there'll be occasional contexts where it really helps to be specific. So I'm going to say this. Some of you may omit it and do so. I would just note at your peril. Okay, now this dot means kind of my sex. It's kind of like an apostrophe S in English. It's the sex of me. This refers to me, okay? But again, you can leave it out if you wish to do so, if you find that more comforting for now. I would like to press this button, build, and you should see a build thing here. Now, the TAs were once strong, but their presence has dwindled. I see only one or two in the room, and I would ask the attendance of other TAs who chat in the foyer. Okay. Let this be the knell that summons them to heaven or to hell. Okay. Ladies and gentlemen, having done that, we've specified a rule for their fill color. Who needs help with this? Please press this button, see if the model compiles. If it does not compile, please summon a TA. You notice I also use this double equal sign. Here I'm testing, is sex female? You don't want a single equals. That would mean make sex be female, which we don't want. We're characterizing here a test. Is sex female? If so, make them yellow. Otherwise, make them gray. This is just a fancy way of specifying an if-else. So if you build it, it should say model built successfully. Who needs TA help? Okay? I would like to run this model now. I'd like to right-click it, run it. And what shall we see now? Who are the gray ones? Who is this yellow one? Well, it's a female. The next one up is male. Next one is female, etc. Okay. A little bit of refinement in light of a future need. We'll go to the oval. We want to change its radius so it's not so glaringly big. How do we do that? What's something we could do? Well, instead of having it rise linearly with age, let's have it rise with the logarithm of age. What do you think about that? Is that okay? Okay, so I'd like to, where would we go to set the radius of this oval associated with each person? First, what would we go to?
Person.
We go to person first, because it's a characteristic of person. Then where do we go within person?
The oval.
The oval, indeed. And within the oval, to where do we repair?
Position and size.
To position and size within the properties of that oval. We go to radius. Right now, it just varies linearly with age. We're going to make this 5.0 plus 5.0 times the logarithm of age plus 1.0. Why such a long thing? Well, if we just did log of age and someone had an age of 0, or someone had an age less than 1, the log of it, someone had an age less than 1, the log of it would be negative, and we might risk a negative radius. If age is 0, log of 0 would be problematic. It would be singular, and we would be in trouble. So we add 1.0 to this. Many of you familiar with biostatistics or other models will be familiar with this trick. We see it in many quarters. We take the log of it, and as the log goes up, we want a minimum age of 0, a minimum radius of 5.0. So even if their age is 1.0 and the log is 0, we want them to have a minimum radius of 5, okay? Even if the age is 0, a minimum. And then it's going to grow as they age by a noticeable amount. Can we run this thing? Are you ready to run it?
Build it.
Okay, build it. Is your model a happy camper? It should say build completed successfully. The TAs stand watchful. They're on guard for thee. Okay, we want to run this. Now we see something whose appearance is less displeasurable. That is recommended by a lesser diversity of sizes, and that lets us better appreciate the patterns of the population. Okay, ladies and gentlemen, here we see a population. It's composed of males and females. The gray at a glance are whom? Who are the gray?
Males.
Males. The yellow are females, and the different sizes are given by what?
Age.
Age, indeed. And if we go in and we browse each person in the population, we'll find that their size reflects their age. For example, this person here is a very young, a newborn, and their size is correspondingly small. Okay, so that's good. That's good. Ladies and gentlemen, a neuron just fired, believe it or not. I'd like to finish this example with something where we have income depend on sex, because we all know that we're faced with unfortunate disparities when it comes to income by different sexes, and that even for the same work, often women are less well compensated than men. And I'd like to characterize that, but I do have a question, because with a little 5-minute departure, we could actually have it so when you click on a person, it'll actually print out the characteristics of that person. How many people would like to see that? 5 minutes? Worth the trade-off? Worth the opportunity cost? Any strong objectors? The ayes have it, by acclamation. Well, okay, not acclamation, but at least by majority vote. Okay, ladies and gentlemen, I've never done this in a boot camp before. Maybe a little bit, but it was a long time ago. Okay, okay, so we're going to have it so when we click on a person, we're going to have it print out information. Where would we go to specify this? What are we clicking? We're clicking on a person, so probably what would it involve in the model? I'm trying to get you to think through where things live in this model, because there's this cacophony of details up here in these projects, and I want you to be able to think through where would I go for something.
Presentation.
Yeah, so we're going to go to person. It's about their presentation, because after all, we're clicking on their what? Oval. Oval is right. Okay, so here we have the oval that stands before us. And ladies and gentlemen, you can carry away from this room today not only a measure of pride on your having known some Java, but you could also carry away pride in peering into the advanced areas of any logic. So I would like you to broach the advanced area of this properties. And you'll notice within the advanced area, there's something that beckons us. What do you see there? On click. Now this, ladies and gentlemen, like many things in any logic that we will see tomorrow, this is our first example of what is called, in the parlance of computer scientists, a handler. Meaning, we're going to put a bit of logic here that handles a click event. When someone clicks, this little bit of code will be executed. Are we okay with that? Let us start, and I'm further going to teach you something of profound significance, but seemingly modest in its formulation. Something that you can use in so many contexts to figure out what's going on in the model and to figure out what's going wrong with your model. The following thing is often ignored, but it's one of the most powerful things you can do in any logic. So I'm gonna emphasize it this time because I have so often failed in this regard. So click on the on-click. You'll notice if there's a little thing here that gives us some information, a little light bulb. And it actually says, it provides us some information. Click X and click Y. It provides us information where it's been clicked, in short, okay? And it's relative to the shape, okay? I'd like to, however, and you notice it says we can access the oval itself with what's called self here, the characteristics of the oval. But here, what we actually want to do is we want to print out the characteristics of the person. And within person, how do we say myself? What was that word we used earlier? That word of such, yeah, what was it? This, indeed, this. Okay? So we're going to get it to print this information out, with pun unintended there. Print this information out. So the way in which you print something out in any logic, and this is the thing, seemingly small step, but of profound significance because it's useful in so many contexts, is something called trace ln. That means print something out, okay? And we're going to say, as a starter, print out myself. Just print myself out. And we'll see that it appears in something called the console. And we'll say, what do we print out? This. Okay, now, it's almost enough for me to hang my head before you in shame. Ladies and gentlemen, I said earlier that in using Java, we are subject to the dictates, to the strictures of those creators of the Java language. As A.E. Hausman said, because we cannot flee to Jupiter or to Mercury, keep we must, if keep we can, the foreign laws of God and man. And so it is. We have to keep the laws of any logic here. The laws, more significantly, of Java. And in Java, this is a request. It's a command. It says, do this. Print this out. It's not a simple calculation. It's not a formula that calculates a value. If it were simply that, we could leave it like that. But for a command, something where we say, do this, we need a special indication to say we're done with that command. And that special indication is nothing less than a semicolon. Ladies and gentlemen, it pains me as a computer scientist, as someone involved in language design and implementation, to see that our languages foist upon your models a cancer of the semicolon. And this is an example of it. The simple rule, repeated oft and repeated early on, is that we need a semicolon if we're telling it do something as a command. But if we're just computing a value, computing a number, we have a simple formula to compute something. We don't need a semicolon. That is the rule. If you can follow that rule and follow it with care, you'll be all set. You'll be in good shape. But a semicolon is indicated in this case, and a semicolon, ladies and gentlemen, we will give it. Are we okay with that? Okay. Hearing no objections, we will go and build the model, and we'll see if it's a happy camper. Now, I'll tell you a secret. Any logic is actually sometimes allows you to omit this because it inserts one itself, secretly. I don't recommend it. You'll test its patience. And if I left this off here, I don't know if it will be happy or not. It might say, oh, I'll fill it in for you. And nope, see that? It says insert semicolon to complete statement. This, ladies and gentlemen, when I pressed that build button, it gave me this problems window. This is a nuisance, but this is your way of learning from AnyLogic what you need to do so that it understands your model. And here, it actually gives you this problem. If you double click on it, it'll bring you to the offending place, and it tells you basically what's needed. Put in a semicolon. There we are. Now it's a happy camper. Does that mean your model is correct? No, but it means it at least understands your model enough to run it. If you press it and it says build completed successfully, it's one happy camper. Okay? Now, whether you'll be a happy camper depends on whether you've characterized the model in a way that captures your intentions. Ladies and gentlemen, computers are outstanding in doing exactly what we tell them to do. But sometimes what we tell them to do is not what we intended to tell them to do. And therein lies the rub. We have to be careful about that. They take our comments literally, and if we're not careful, our literal comments might not reflect our intentions. Ladies and gentlemen, you can run the simulation. By running the simulation, we'll see these lines. How could I get it to print something out? How could I test if my code is actually working? Click. Ladies and gentlemen, click. Now, when I click, I actually don't see something immediately, but let's go over and, it's because it's below my screen. Do you see that? Do you see? It's printing out. Notice it says, okay, I'm printing out population member 99. Their age is 78 years old. Notice curiously, it actually did not print out their sex. Okay? If I wanted to print out their sex, I could do so. How would I do that? Well, let's stop the model. Let's go back to that. And here we go. We'll go down to the bottom here. We'll say trace ln of this. And we could say, and my sex is, and we'll put plus this dot sex, my sex, the sex of me. Okay? The plus just means put the strings together, put these sort of sequences of characters together. So first under me, and then it will say and my sex is, and then it will put my sex after that. Yes?
So why does it pick age and no sex to when you say this?
Yeah.
This is not characterized by dog?
Okay. So my answer to that, and I actually, if Winchell were here, I would really value his comments. My answer to this is singular. It's mumble. Okay. So I actually expected it to print out sex there. I think it's because it's the first characteristic we added, and all it does is provide perhaps the first characteristic. But I encountered that output with surprise and no shortage of displeasure. We will get an answer to you about that within the next day, because I don't like it. It's an easy workaround to supplement additional information. But I believe there's a way we could trivially get it to print more information. All right.
My guess is we defined that type. If it was an integer, it would have displayed it, but it's a sex. So
okay, so that's another great hypothesis, and one that can be tested in a straightforward way. We will get that answer for you, Gabriella. and provide it by tomorrow. Okay, if we go click on here now, you'll notice it starts with that. It prints out who this person is, what their age is, and my sex is female. Do you see that? So now it reports their sex. And we could do so with other characteristics. You'll notice it's specifying the person number. That 36, where else have I seen this kind of numbering of agents? Where else have I seen that? Does anyone remember?
Yeah.
In the,
Population.
yeah, in this thing down here. That's population 0, 36. Well, I could even fill it in. 36. There's that right there. And you'll notice that their age is 17.085, and that matches what's shown here. Okay? They're a female, and that matches what's shown here. So we see a correspondence. We see a consistency between what's reported, in the visual interface and by clicking on people. This clicking interface is quite a useful one when you want to try things interactively with your model. You can get it to undertake interventions on this person. You can get it to figure out what's the unique characteristics of this person that's distinguishing them in terms of their health status. You can find out about their history by clicking on it. It's a very powerful mechanism, and it's one that's available to you readily through that advanced technique. So buoyed by our confidence that we have, even in our first day, penetrated what is termed an advanced theory of any logic, I want to add the final step of our example here. And it's a step of significance for us in the health sciences area. And so I'd like to approach it and dispatch it before we depart for the day. Ladies and gentlemen, I would like to go and I would like to add in to this from the agent palette. I'd like to add in a parameter here. Okay? And Eric, if you wanted to investigate that and render judgment about why it shows that, we're going to add in a parameter called income. What sort of thing will income be? What's its so-called type? What sort of quantity is it? From what universe of possibilities does it draw? Is it a Boolean? Is it an int, an integer, or a double? Is it a string or a date or a sex? What is it, do you think? It's a double. Yeah, we'll treat it as a double precision value. Okay. It's essentially a continuous quantity, so we'll specify it like that. You'll notice that you can, with these parameters, you can specify a default value. It's a value if we didn't specify it for the population, it would use that value. And you may want to fill that out. It doesn't have profound significance, but we'll give these individuals a default income of $10,000 a year. Are we okay with that? Okay. But ladies and gentlemen, this is indicating a the fact that we've added this as parameter indicator, so our theory of personhood includes having an income. But where for a particular population do we specify the characteristics of income that apply to a particular population? In Maine, and associated with the what? With the population, indeed. Okay. So let's go to the population here. To the population we repair in Maine. We go down Maine, and we encounter this. Okay. Next, I'd like to draw the income from a log normal distribution because income is somewhat skewed, particularly in certain countries. It's quite skewed. I'd like to give it a log mean of 11, a log standard, so that would be mu, for those of you familiar with log normal distributions. I'd like to give it a sigma, a log standard deviation of 4.0, and it demands an additional value. Now you notice that I engaged in unpleasant behavior there. I engaged in downright irresponsible behavior. I should have typed log and controlled space and filled it out. I don't want to treat you with develop adverse habits in my students. And you notice when we do this, one of the advantages is it will actually tell us about what we have to give it to do its job. These are the so-called arguments, the so-called parameters it needs to do its job. We need to specify mu, sigma, and a minimum value at which we want to truncate the values. Okay, so I'd like to give the log normal again, 11.0. You'll notice if we choose that, it will actually sort of tell this to you. 4.0 and a minimum of 0. It can never go below 0 in a log normal, but we'll use that anyway. Okay? I would also note that any logic has a rather nice feature of having this distribution picker up here, which allows you to choose from many distributions that it allows you to select. For example, a gamma distribution or an exponential, a beta distribution here. And you can actually play around with these values and see what their implications are, and find which of them seems to be a best capture your interests. We could choose any number, including log normal here, etc. It's not perfect, but it gives you a leg up. Ladies and gentlemen, here we draw from log normal distribution with these characteristics for their income. So let's run the model. We go to projects, and I will build the model. I should have done this just to check if it's a happy camper. It seems to be happy. So I'd like to run the model. Okay, here we go. And now we can go down to the population. We'll find that there's a diversity of incomes. Here's a fairly well-to-do female. Here's a female of indigent means. Another individual with lower income, and an older pensioner. So by going through the population, we can see individuals, some of them well-heeled, and of an age that suggests retirement. Okay, ladies and gentlemen, we provided an income, but there's something that's sticking in my craw. Besides my sore throat from my instruction, there's something else that's bothering me. And I'll attack that in two ways. The first is I'll ask one of the TAs to get me a bit of tea. The second way, though, thank you very much. Really appreciate that. The second way is I want income to depend on some other characteristics. I mean, after all, right now, we're drawing age from a distribution. We're drawing sex from a different distribution. And we're drawing income from a distribution with no consideration of the other characteristics. Often there's profound covariance between these things. A person's income may, for earlier decades of life, rise with age. Thank you so much. And the final few decades may decline. We'd like them at least to be associated with this. And for different sexes, as we know, there's big disparities for the same work. Women are not part of the boys' clubs that so often dictate the dynamics of organizations, even in the 21st century. So I'd like to have income tied in with other things. Any logic does not support, regrettably, joint distributions to be specified directly. There are ways of accomplishing this that are only slightly more involved. And if anyone really, really wanted that, we could affix you with the right TA, and before Wednesday is out, we could show you a model that very nicely can draw from a joint distribution, perhaps even by the end of tomorrow. But what we do instead is we draw from conditional distributions. So we specify each and sort of in a Gibbsian fashion, Gibbs sampling type fashion, we specify one distribution as it depends on the other. So rather than specifying a joint, you specify marginals and conditional distributions. So income here, income, ladies and gentlemen, is going to depend on sex, we'll say. How will it depend on sex? Well, what we're going to do here is we will, for main, we'll specify it for a population. We'll go to the population here, and we will say the income, instead of just being drawn from a log normal distribution, we'll actually draw it from a distribution that depends, a different distribution for men and women. Okay? How would I do that in any logic, ladies and gentlemen? Remember I told you something before, not an hour thence. I gave you some guidance as to how you could say, if this is the case, use this, otherwise use that. Where do we see that sort of logic? Yeah, the sex distribution associated, or the sex associated with selecting a color. So we're going to need to do a similar thing here. We're going to say, if my sex is male, use one distribution, my sex is female, use another. Are we okay with that? Okay. There's a slight twist, and this is one of the reasons I'm teaching you this. You'll notice that there's a little light bulb there. And it gives you some guidance. But there's one point of guidance that it doesn't tell you, that in my view is equally important. To refer to my sex for this particular person, the person is not yet created. We're in the process of creating it. The person is not yet there. So this doesn't apply because I'm not yet created. We're getting together the characteristics by which we will create that person. And before their birth, there's no this. Before they're coming into being, there's no this. So for their income, we will actually need to say self.sex. If their self.sex, the self of the person coming into being is male, we will use a log normal with 11, log mean 11, and log standard deviation 4, and otherwise we'll use log normal with 10.0 and 3.0 log standard deviation and a minimum of 0. Now, this little formula we've given, well, it's logically succinct. It is abbreviated visually by the size. So I'm going to drag this over here. Alternatively, I could have double-clicked on this and made it full screen, and then we can see it. If self.sex equals male, log normal of this, otherwise log normal of that. Some in the audience may, like those of your instructors, be encumbered with tired eyes or eyes that are suffering the ravages of age. So I'm going to actually put this in a larger font. I'm going to create a display for this where I will use a font that's larger here and mumble. Okay, so I should be able to enlarge font. Here we go. Boom. This perhaps is more readable even from the back, and I'll expand it yet more. Okay, how do we read that? We say, well, look, if our sex is male, why double equals and not equals? Yeah, we're testing, is their sex male? If we want to assign their sex to be male, we would say equals. But we don't want to do that. We want to ask, is their sex male? We have to use equals to mean this. We're testing equality. We're asking, are they equal? And what does this question mark mean in the colon? Well, what's after the question mark is if this is true, if they are male, we'll use this distribution, draw from this distribution. After this, we'll say if they're not male, draw from this. Are we okay with that? Okay. So this is kind of an if-else type of thing. In R, we have if-else constructs. Different languages support this in different ways. Ladies and gentlemen, is this performing a command saying, do this? Imperative, thou shalt do this. Or is it computing a number? What is this doing?
It's
It's actually computing a number. What we get out of this whole thing is a single number. It's either a number drawn from this distribution or this one. It is doing some work in the process, but we're not just purely saying do it. We are expecting a number back, and because of that, because we are using the result of this to determine their income, we're using the result of this to get a number to assign for their income. We actually don't need a semicolon. This is unafflicted by the cancer of the semicolon. Okay, ladies and gentlemen, are we okay with this?
And how about age?
Okay, so we could have it depend on age. The time is a fleeting, and if we want it to depend on age, what could we do? Let's think about that. Well, one thing we could do is we could draw from a distribution that includes, some characteristic of sex, some beta times 1 or 0, depending if the sex is male or female, and then some other coefficient for age, and use that to draw from a log normal distribution whose log mean and log standard deviation depend on both of those as determined by a regression, for example, a log normal regression. That would be something we can do. With your leave, I'm going to skip that for now, but a TA could show that to you, and by popular demand, if that were a need, I could show how to do that in the morn. Okay? Yes, question?
So essentially what you're saying is you have to create distributions. There's no way to directly put in a regression model there that would depend on multiple variables.
You could do so. It wouldn't be hard to do so using a construct I haven't introduced today by choice because it would complicate the initial dialogue. There's actually a very easy way to do it, but I've left that till tomorrow. And that mechanism is something called called a function. Okay. So if we go here, you'll see there's a thing called a function, and that would allow us very easily to put in a little regression model, and in one line or two, we can capture that logic of having the income depend on those two things. It's a function because it encapsulates some logic which would make this pretty big, and I wouldn't want to write it out here because you'd be copying down a lot of stuff. And more to the point, we could also name it with a clear name, and maybe later we adjust the coefficients associated with that. And instead of writing out and hard coding it here, we put it in a function that has a clear name where we could go, and that's its job in life, to put it there. And it's very easily done. And before the sun sets tomorrow, and most emphatically before the next eclipse, you'll see how that's done. Okay? Yeah. We'll use functions. And I'll use functions with a measure of delight that may not be shared by all of those in the audience. Okay. The final thing I'd like to do is to set, instead of having the oval radius depend on age, on age, yes, I'd like it to depend on income. How would I do that? Anyone? Where would I go? Now we want the oval to have a radius that's dependent on the income. Yeah, person, it's a characteristic of person. And more than characteristic of the person, within a person, it's a characteristic of the oval within that person, their visual appearance. So we go there, and you notice, by the way, it hasn't been very helpful. It's still sticking. By appearances, I've selected this, but somehow it's sticking in person. I don't like that at all. I could go back and go select it, and now it gets to oval. Sometimes any logic gets stuck in this, or it's showing the wrong thing, and I don't like it. And it occurs with occasionally for me, enough that it's kind of a nuisance. Sometimes I go over here and just do person, and I select oval, and there it goes. I don't have to navigate visually to it. It's just part of this interface. Okay, so where would I go to set this characteristic? Yeah, if for a radius, instead of depending on age, I'll have it depend on income. Whether we want it to be 5, let's change it down to 2, because the range of incomes is considerably larger than the range of ages. After all, these are dollars per year. Are we ready? Shall we proceed? Shall we run the model? Okay, let's run it. You notice I reflexively save. That asterisk, if it's posed to you, then you probably want to save your model. Okay, you can run the model here. What does a bigger oval indicate here?
Green.
Okay, yeah. So it's a big oval indicates that they are what? Rich. Say it like it is.
Narrow.
So this is a person with an income well over $100,000. It's a 21-year-old male. There's another individual who's dealing with a much smaller income. And if we go further along, we may find someone who complains because his father only gave him what he terms as a small loan of $1 million. But whose appearance is greater than his actual income. Okay, ladies and gentlemen, we see now that we have a way of relating these characteristics. Now, you notice that getting back to Eric's hypotheses, we had different hypotheses for why it wasn't printing things out before. One hypothesis was that sex was optionless, so it wasn't printing it because of that. Another was maybe it only prints the first. I'm clicking on these things. Now we have 2 numeric characteristics. So now the moment of truth has arrived. We'll be able to falsify one of those hypotheses. We go in and we look. We see what it's printed out. Oops. Here we go. Is it printing out income? It is. Eric's hypothesis is vindicated.
And I have a fix as well.
Okay, speak on, young man.
So if you go to person,
Yeah.
on advanced,
Yep.
there's an option to create 2-string.
Okay.
And actually all you need to do is hit create, and then it'll work.
Okay. So, Eric, this is the first time that this knowledge has been expressed in my boot camp. And it's the first time, no less, that I acquired this knowledge. So I'm grateful to you for uncovering that. Okay. So I go to person here. And what you're saying is I go down and is it advanced Java?
Just advanced.
Just advanced. Okay. Okay. And I go down and there's a thing that says create 2-string function with parameters. And if I understood you correctly, we could press that button. And now we will have a more advanced agent that presents itself. By running the model now, I'm going to run it now. And here we'll go. And I will now click. And we'll go look to see what's printed out and how it differs from before. And now you'll notice it prints out the full set of characteristics. Not just their age, not just their income, but also their sex. Eric, I'm grateful. That's great. An interesting question is if we added another parameter, would we have to throb that button again to get it to immediately print that parameter, or would it know to do that? And that's something which I will leave as an exercise to the viewers. Okay? Okay, great. So, ladies and gentlemen, we have now a little model. A model that is a certain amount of richness. We have age. It has a certain amount of descriptive complexity. We have age, we have income, we have sex. We have income that depends on sex, and I've indicated a way in which you can depend on income as well that would be within easy reach of the TAs in the room. But there's something that's lacking from this model. What is it? There's something that's absent from the model that is central to the mission, the vision of dynamic modeling. Time in terms of changing state. Right now, we see characteristics of a population that's rich in heterogeneity, but bereft in terms of dynamics. So, as our final element for this afternoon's hands-on exercises, I would like to introduce into this model a little bit of dynamics. Okay? Okay. So, ladies and gentlemen, we are going to associate with this model an evolution of state that is associated with development of some affliction. Okay? And that affliction will, in this initial rendering, not depend on those characteristics. We'll see by tomorrow ways in which we can tie it in, but initially it will not depend on those characteristics. So we're going to go to person, and we're going to drag into person a state chart. Okay? And this state chart will include, it'll be called a diabetes state chart. Okay? We're going to drag in to that state chart some states. The first will be normal glycemic. Mark my words. This is a point of significance. We're going to be exploring several ways to characterize dynamics of agents. We'll see the use of state charts. We'll see stocks and flows. We'll see variables. We'll see ways of triggering things based on messages. Where do these fit together? Which one is appropriate in different circumstances? Ladies and gentlemen, if I'm thinking about an agent as having a state that's delineated by a set of categories, they're categorical quantities, different distinguished states they could be in. State chart is normally a point of gain. It's a discrete set of categories with some transitions between those categories. We normally look to state charts. If we have continuous variation, we think of either variables or system dynamics formulations with stocks and flows. There's other aspects of interaction with the environment that are captured by messaging. Okay, normal glycemic here. We will have pre-diabetic. And finally, we're going to have full-blown frank diabetes. Okay. Are we okay with this? Okay, ladies and gentlemen, we're going to put a transition between these states. So how did we do that? We went to agent and we dragged in a transition, and I connected it on both sides such that it is green. Green is the color. State charts are the game. We connect on both ends and building a complete state chart as our aim. Okay? Great. So associated with this, so a transition specifies an action, but it also specifies the rules under which that action applies. The action is switching states. The rules under which it applies here are indicated by these properties over here. Okay? So the properties let us say, okay, what sort of action is this, or what sort of transition? Is it based on a condition, receiving a message, arriving at a destination, or a timeout, a sort of a fixed amount of time after they come in, as perhaps drawn from a distribution or using a number? We're going to say this is a rate. And it will be a rate here that's quite small. The rate in this case will be 0.02. Okay? So, excuse me, yes. This is just truncated. Oop, not 10.02, 0.02 per year. This is a hazard rate, a chance per unit time, much like the hazards you may have worked with in biostatistics. If you want to think about it, in this case, it's an incidence rate associated with pre-diabetics. Amongst those at risk, namely normal glycemic, what's the chance per year that they develop pre-diabetes? And similarly, we will go add from the palate a transition from pre-diabetic to diabetes. Okay? And that too will be associated with a rate. And that rate will be higher. It'll be 0.1 per year. Okay? Now, right now, I'm just making these numbers. Of course, these will typically depend on characteristics like people's age, people's risk behaviors, people's weight, for example, perhaps, which might itself be variant. We'll get to that. But just as one eclipse is enough for the day, I think a single state chart will wrap out our characterization of dynamics for the day. So here we have individuals changing state. An individual enters at this point, hence the state chart. You'll notice the resemblance of this to that system CQHM, which we demonstrated earlier. That's not an accident. They enter in here, and then they have a certain per year hazard of going to here and a certain per year hazard of going there. We could easily make these depend on age, sex, etc. We'll leave that for later. Okay. Now, if we run this model, will we see anything different? I'd like you to build the model and make sure it's a happy camper. Perhaps one of you has inadvertently left these unconnected, like this. And if you try to build the model, it will indicate two errors. You'll notice that there's a confusing thing that occurs in any logic. And I find it actually a little bit shocking, but you'll notice sometimes it says two errors here, but it says build completed successfully. This is pretty confusing. You'll try to run the model, and I believe then it will indicate problems. Errors exist in required projects. If you have errors, you want to go to those errors and you want to fix them. So here, you notice it says a hanging transition. The element is not reachable. If you double click on this, it will show you what thing is troubling it. This is an indication that it doesn't understand your model. It's like I used an ungrammatical sentence. Loud green ideas sleep furiously, or something like that. Actually, that's not. It's a semantic error, not a grammatical error. If I said, I know, understand. We'd say, okay, are you saying you don't understand? It's not a grammatical error, or yeah. Anyway, I won't try to create ungrammatical examples. Okay, so ladies and gentlemen, here it's an indication it didn't understand what we meant. We connect this here. It's a happy camper. We can build. It says no errors. We're fine. If we run this model, will we visually see anything different? Will we see something different appearing before us?
You go to the population.
If you go to population, we may see this. And you'll notice time is passing here. Time in years is moving on. This is a normal glycemic individual. And if we run this Eventually they go pre-diabetic and they develop diabetes. But visually we don't see anything yet. So there's finally one thing to do. One thing that I'm going to do here. I'm going to make their color some visual aspect that denotes their state. And we can do this in one of two ways. And I turn to you for guidance. One way we could do this is we could change the color. Instead of depending on sex, we could make it dependent instead on their status here. Alternatively, we could make the ring around them, not the fill color, but the ring around them change colors, still retaining the dependence on sex for the basic color for the fill. Which would you prefer? How many would like me to change the ring around? How many would strongly prefer me to do fill color change? Okay. Ring around, it takes essentially no more time. Are we ready for it?
Yes.
Okay. So I'd like you to go to the palette. We're going to need to determine what their color is. How did we make it depend? How did we make their color depend on their sex right now? Where would we go to see what logic we put in there?
Oval.
Go to the person, the oval. Yeah.
And then
Here we go, and we go to fill color. And you notice we said this, okay, if they're female, this one, otherwise that one. But we have 3 states that are possible. And it could get pretty messy to put out a long thing like that. One way to deal with it would be a function. But I'm saving functions for tomorrow. The other way to deal with it is by a slightly more advanced feature. But I'd like to introduce you to it. And that's something called a variable. I'd like you to drag in from palette a variable. And this variable is going to be called color. Now the question is, how do I spell it? This could be a matter of some contention. Well, the Australians and Canadians amongst us have to take insult upon injury by repeated adherence to the dictates of the American Imperium. So I'm just going to say color with a U. Okay, and if you want to spell it with a lowercase without the U, you can do so at your peril. The type of this, well, it's something drawn from the set of all possible colors, and the set of all possible, just like sex was drawn from the set of all possible sexes. It's not one of the predefined choices here, so we have to say other. And what could we put here to indicate set of all possible colors? We spell it with a capital C, just like we spelled sex with a capital S to indicate all possible colors, or person with a capital P to indicate all possible people. So we're going to say the type is, and this one has to be spelled this way. It's a built-in thing. Java was created in the US, and the naming conventions of the US hold. So we're going to say COLOR, color with a capital C. Color. Its initial value will be black. It's initially going to be black. If we don't change it, it's going to be black. Okay? That's this color variable. Now, how would we make the color of the oval depend on the color in that variable? What would we do? We need to, sorry? Yeah, we have to go associate them. So instead of doing it for fill color, we'll do it with line color. Okay, I'd like to make it that color. How do I do this? I need to turn it to a dynamic variable. And I'm going to say color. Do I need a U? Yes, I do. I could spell it out, and you'll notice it only gives me one chance. Color. Spelt with the proper Queen's English. Okay? Okay. Are you ready for that? Okay. Okay, great. What if I ran the model? What would we see now? maybe we'll make this line be thicker. We'll give it a width of say 3 points. Okay? 3 points. It'll be a thicker line. What would we see if we ran the model?
See it changing depending on the state.
Okay, that's where we'd like to go. Have we put in that logic? All we said is there's this variable color, it's initially black, and this thing will depend on it. But how do we make it so it changes?
D,
Sorry?
you have to add the code.
Yes, we have to add a little bit of code. And the horror begins. The horror continues. The horror for the day will soon be gone. Okay? So, for each of these states, we're going to need to say, make the color something different. So when they enter a normal glycemic state, we will make that color be green. And we need to do this in an action. Just like we set the on-click handler before, this is a handler for when we enter the state, we will assign color. By the way, I forgot to say this dot color. To be consistent with my aspirations, I should have done that before. It's implied, but I like to be consistent to avoid throwing off my students. So for the entry action, I'm going to say this dot color, autocomplete, equals green. Why a semicolon? I am commanding it, be green, make yourself green. Make this variable green. This is not computing a number. It's saying, thou shalt be green now. Thou shalt make yourself green. You know, greenify yourself. That's what that's saying. Okay? Green thyself. Are we okay with that? Hence the semicolon. We're saying, do it. We're not asking for a result. We're just saying, you better make yourself green. It's an imperative. It's like an exclamation point in English. Not like a question, but like an exclamation point. Okay. Build early. Ladies and gentlemen, build often. Make sure it's happy. The TAs, this room is now well stocked with TAs. They sit ready for you. Who needs help? Help? Help is on its way. Sector 2. Who else needs help? Sector 2. Help help is being conferred, it appears. Right in front of you, I think. Right there. Right there. Yeah. Tina's helping. Okay, I couldn't see the hunching figure. Okay, let's go to pre-diabetic. Thank you. Okay, let's go to pre-diabetes. How would we change it so it's yellow for pre-diabetes? Tell me what to type. This dot color, and why type it? Autocomplete is our friend. And most importantly, autocomplete is also the TA's friend. Okay? Equals what? Do we want double equals or single equals? Single, because we're saying assign it to this, make this the color, not testing whether it's equal to. If it's testing whether it's equal to, we'd use double equals. But this, we're saying do that, assign it to it, okay? Make it so. This dot color equals yellow. Do we need a semicolon?
Yeah.
Indeed we do. We're telling it, thou shalt be, make yourself yellow, okay? Yellowize yourself, yellowify. Okay, and for diabetes, how would we do it? This dot color equals red. Good. Okay, what would we see now if we were to run this model? What apparition would stand before us? What specter haunts this model? Let us run the model. You have nothing to lose but your uncertainty. Okay? What do we see? What are these red individuals? What about those? Or what's this person who's all yellow with no border, it seems, at all?
Diabetic.
That's a pre-diabetic. These individuals with red are what? Diabetic. Look, this is a pre-diabetic here, and in the fullness of time, the deprivations will set in where they'll turn diabetic. Do you see that? Mm. Mm. So here we have some dynamics. And alas, as the years creep upwards, centuries pass, and empires rise and fall, we see the population falling prey not only to the ages of Methuselah, but a chronic disease burden to accompany it. Okay? Ladies and gentlemen, we just characterized dynamics. This is a model with heterogeneity. That heterogeneity is not yet captured in the dynamics, but tomorrow we'll see ways of doing so. But we also have dynamics associated with each agent, and those dynamics induce, in this case, color changes. So an individual can be one of several states, and their appearance can reflect that. The time is late, and I think I shall release you for the evening. Yeah.
Let's just say good day.
Oh, okay.
It wasn't, I'm going down.
It's fitting in either way. That's very kind. And I appreciate at least not dispute of release. I would ask you to pursue one thing tonight and struggle with it if possible. And tomorrow I'd like to discuss it with you. It's an important one, and it goes back to something we saw earlier. I'm going to stop this recording.